In Oracle, background processes are responsible for managing various tasks and functions to ensure the proper functioning of the database. PMON, Process Monitor. PMON is responsible for process cleanup and recovery, monitoring the status of other processes, and managing process registration and communication. SMON, System Monitor. SMON performs instance recovery, coalesces free space in the database, and deallocates temporary segments. DBWN, Database Writer. DBWN writes modified database buffers to data files on disk. There can be multiple DBWN processes, such as DBW0, DBW1, etc., depending on the configuration. LGWR, Log Writer. LGWR writes the redo log buffers to disk. It ensures the changes made to the database are recorded in the redo log files, which are crucial for recovery. CKPT, Checkpoint Process. CKPT signals the DBWN process to write modified buffers to disk and updates the checkpoint information in the control file. CKPT updates the database control files and data file headers to indicate the most recent checkpoint. It helps in database recovery and reducing the time required for database startup. SMCO, Space Management Coordinator. SMCO coordinates the background processes involved in space management operations, such as space allocation and deallocation. MMAN, Memory Manager. MMAN manages the system global area, SGA, by dynamically adjusting memory allocation and distribution among various components. MMON, Manageability Monitor. MMON collects statistics and performance data for Automatic Workload Repository, AWR, and advisory features. RICO, Distributed Transaction Recovery Process. RICO handles distributed transaction recovery when there are failures or inconsistencies in distributed transactions. MMON, Manageability Monitor. MMON collects statistics and performance data for Automatic Workload Repository, AWR, and advisory features. RCN, Archiver Process. ARCN is responsible for archiving the filled redo log files when the database is in archive log mode. Archived redo logs are essential for point-in-time recovery and can be used to supplement the current online redo log files. Job queue processes. JNNN job queue processes manage and execute scheduled jobs submitted by users or automated tasks defined within the database. CJQ0, Job Queue Coordinator. CJQ0 coordinates job scheduling and execution for Oracle's Job Scheduler, DBMS_scheduler. DIAG, Diagnostic Process. DIAG captures diagnostic data and error information in the Automatic Diagnostic Repository, ADR, for troubleshooting and analysis. VKTM, Virtual Keeper of Time. VKTM is responsible for managing the database's time-related functions, including heartbeat and synchronization. WMON, Service Manager. Background Process. WMON manages connection and dispatcher processes for shared server configurations. Dispatcher, DNNN dispatchers manage incoming network connections and distribute them to the shared server processes. They are part of the Oracle shared server architecture. Lock Manager, LMD. LMD manages and coordinates locks on database resources to ensure data consistency and concurrency control. Oracle Real Application Clusters, RAC, is a feature of Oracle Database that allows multiple database instances to run on different servers, forming a cluster. In Oracle Real Application Clusters, RAC, there are two types of processes, Oracle RAC daemon processes and background processes. Some of the important background processes in Oracle RAC are LMS, Global Cache Service Process. The LMS processes manage global cache resources and perform global cache operations. They handle the cache fusion process, which is the mechanism used to transfer data blocks between instances in a RAC cluster. LMD, Global NQ Service Daemon. The LMD processes manage and handle global NQ requests. They coordinate the allocation and deallocation of resources across the cluster. LMON, Global NQ Service Monitor. The LMON process monitors the health of the global NQ service. It performs recovery actions if required, such as remastering of resources in case of instance failure. LCK0, Instance NQ Process. The LCK0 processes handle instance-specific NQ requests. They manage the allocation and release of local resources within an instance. LCKN, Instance Lock Process. The LCKN processes manage instance locks and handle lock conversion and escalation requests. They coordinate concurrent access to shared resources within an instance. LMSN, Instance Cache Service Process. The LMSN processes manage the instance's local cache resources. They handle the cache fusion process within an instance, transferring data blocks between cache and disk. RMSN, Remote Mapping Server Process. The RMSN processes manage remote mapping requests. They provide the mapping information required for accessing remote data blocks. DIAG, Diagnosability Process. The DIAG processes collect diagnostic data for troubleshooting and monitoring purposes. They generate trace files and diagnostic dumps when errors or critical events occur. Oracle RAC Daemon processes. Oracle RAC Daemon processes are specific to the Oracle RAC environment and are responsible for managing and coordinating the activities of the cluster. These processes work together to provide high availability and scalability in a clustered database environment. Global Cache Service, GCS, process. The GCS process manages the Global Cache Service, which coordinates the access to the shared data blocks across the RAC instances. It ensures data consistency and coherency in a multi-instance environment. Global NQ Service, GES, process. The GES process manages the Global NQ Service, which provides distributed lock management for the Oracle RAC cluster. It handles the serialization of database resources, such as tables or data blocks, to prevent conflicts between concurrent transactions. Global Resource Directory, GRD maintains information about the status and location of database resources, such as data files, control files, and online redo logs. It allows the Oracle RAC instances to access and manage these resources in a coordinated manner. Network Communication Processes, LMS and LMD. These processes handle the inter-instance communication in Oracle RAC. The Local Message Service, LMS, process manages the communication between instances, and the GES Daemon, LMD, process handles the uncurrelated communication. Cluster Synchronization Services, CSS, CSS is responsible for synchronizing configuration information and maintaining the consistency of cluster state across all nodes in the cluster. It ensures that all instances in the cluster are aware of each other and can cooperate effectively. Oracle Clusterware Process, CRSD. This process is the core component of Oracle Clusterware. It manages the cluster resources, monitors the health of cluster nodes, and coordinates the activities of other clusterware processes. CRS manages the availability of Oracle resources and services in the cluster. It monitors the health of resources and performs automatic failover or relocation of services in case of failures or planned maintenance. Process Monitor Daemon, OPROCT. This process monitors the cluster and provide I/O fencing. OPROCT performs its check, stop running, and if the wait is beyond the expected time, then OPROCT resets the processes and reboots the node. OPROCT failure results in Oracle Clusterware restarting the node. Event Managed Daemon, this process publishes events that CRS creates. Oracle High Availability Service, OHAS monitors the health of Oracle RAC instances and provides high availability services, such as automatic restart of failed instances and failover of services to other instances. Oracle Notification Service, ONS enables communication between different components of Oracle RAC. It notifies the instances about configuration changes, such as addition or removal of nodes, and facilitates communication for workload balancing and service management. RACG, RAGMain, extends clusterware to support Oracle-specific requirements and complex resources. Runs server callout scripts when FAC events occur. Oracle ASM, Automatic Storage Management, is a feature of Oracle Database that simplifies storage management and provides a foundation for Oracle's database cloud solutions. ASM is responsible for managing the storage resources used by the Oracle Database, including data files, control files, redo logs, and archived logs. In the background, Oracle ASM employs several processes to perform its tasks. Here are the main background processes in Oracle ASM. ASM instance, ASM1. ASM runs as an instance separate from the Oracle Database instance. The ASM instance manages the ASM metadata and performs tasks such as disk discovery, rebalancing, and metadata operations, ASM Disk Group. A disk group is a collection of physical disks managed by ASM. It is created and managed by the ASM instance. ASM Disk Group processes perform various operations on the disks, such as disk discovery, rebalancing, and redundancy management. ASM rebalance, ARBX rebalancing is the process of redistributing data evenly across all disks in an ASM disk group. The ASM rebalance process, ARBX, manages the rebalancing operations, ensuring that data is evenly spread and that newly added disks are incorporated into the disk group. ASM Instance Monitor, ASMB. The ASM Instance Monitor, ASMB, process monitors the health and status of the ASM instance. It performs tasks such as resource allocation, monitoring disk group status, and providing status updates to other ASM processes. ASM Metadata, MMON. The Manageability Monitor, MMON, process manages the metadata within ASM. It collects statistics, performs space management operations, and handles other metadata-related tasks to ensure the efficient functioning of ASM. ASM PowerMaster, PWRN. The PowerMaster, PWRN, processes handle the rebalancing of power across ASM instances in an Oracle Real Application Clusters, RAC, environment. They coordinate power transitions and help maintain a balanced power distribution across instances. In Oracle Dataguard, there are several background processes that play crucial roles in maintaining and managing the standby database and its synchronization with the primary database. These processes include LogWriter, LGWR. The LGWR process is responsible for writing redo log entries to the online redo log files. In a Dataguard configuration, the LGWR process writes redo data to the local online redo log files, which is then transmitted to the standby database. Archiver, ARCN. The archiver process is responsible for archiving the filled online redo log files on the primary database and transmitting them to the standby database. Each archiver process is assigned a unique identifier, ARCN, where N represents a number. Remote File Server, RFS. The RFS process on the standby database receives the archived redo log files from the primary database and applies them to the standby database. It reads the archived redo log files transmitted by the primary database and writes them to the standby redo log files on the standby database. Redo Apply, MRP. The Managed Recovery Process, MRP, applies the redo data received from the primary database to the standby database. It continuously applies the archived redo log files to the standby database, keeping it synchronized with the primary database. Dataguard Broker, DMON. The Dataguard Broker process is responsible for managing and monitoring the Dataguard configuration. It automates various tasks such as switchover, failover, and monitoring the status of the primary and standby databases. Log Transport Services, LNS. The LNS process transmits the redo data from the primary database to the standby database. It sends the redo data over the network using Oracle Net Services. Log Apply Services, LNS. The LNS process on the standby database receives the redo data transmitted by the LNS process on the primary database and applies it to the standby database. Oracle Export and Import are tools used for data migration, backup, and recovery in Oracle databases. When performing an export or import operation, there are several background processes involved. Master Process, EXP. This process manages and coordinates the entire export operation. It controls the worker processes and monitors their progress. Worker processes. These processes perform the actual data export by retrieving data from the database and writing it to the export dump file. IMPDP, Import Data Pump. Master Process, IMP. Similar to the export process, the import master process coordinates the import operation, controls worker processes, and manages the import job. Background processes, for both export and import. Job queue processes, JNNN. These processes manage the job queue and execute export or import jobs submitted by users. Queue monitor process, QMNN. This process monitors the job queue and dispatches job requests to the job queue processes. Data Pump Master Controller Process, DMCN. This process coordinates the actions of data pump worker processes and manages metadata. These background processes work together to facilitate the efficient and reliable export and import of data in Oracle databases. The number of worker processes and other settings can be configured to optimize performance based on the system resources and requirements.